Okay, I wanted to start this video off with some familiar formulas. So although we will be dealing with sectors such as the problems listed on this page, let's first explain where the formulas come from. Now, if you're great at memorizing, here, let me go ahead and write them really quick. We have S equals R theta, and that's for arc length here. And then the area of a sector is 1/2. So the area is 1/2 theta r squared. However, on an exam, you may need to memorize those. So where do they come from? That's what I want to talk about for a minute. So an arc length, what we are talking about, right? Suppose you have a circle. Now, for this unit, here's what we're talking about. I have a circle, and suppose we had, like this first example, whatever, some sort of angle, and okay, think of like a pizza pie, right? I'm talking about what is this length. So even in the real world, right, like maybe it was a small measurement, you could get a ruler for anything that is straight, but how do you measure curvature precisely? So that's where we're going here. All right, well, we have a familiar formula for the entire arc length, right? The entire circle. A full circle, we just call that circumference. Right? So if we have a full circle, we know the circumference. That formula is 2 pi r. Well, we're not doing a full circle, right? We're only doing a ratio, a part of a circle. But we could still kind of think of all right, how does that come from? In radians, a full circle is 2 pi. See, maybe high school geometry or even before that, whenever you first learned about circumference, you're given these magic formulas, you weren't technically told anything about radians, right? But 360 degrees is 2 pi. So it kind of makes sense, all right, I took the entire angle multiplied by the radius, that gave me circumference. So if the angle is less than 2 pi or anything, right, then ideally what we're saying is we just take whatever angle that is, theta, and multiply it by r. Now, we no longer call this circumference, because circumference really is a term, a vocabulary term for the, you could think perimeter of the entire circle. So they change it to an S. I don't know what that S stands for. Something Greek, I would assume. But anyways, notice the formula they give S equals R theta. But really, if you derive it from circumference formula, it's S equals theta R. It just rolls off the tongue better. That's my guess. Many formulas we have, they're written the way they are because they roll off the tongue better. S equals R theta. Now, it's important to note, and why I did this first example, that the theta, the measurement of the angle, is in radians for this to work. So if you have your angle in radians like the second example, you're set. You just multiply by the radius, use a calculator, whatever, you're done. Okay. Area. So an area of a full circle, right, the entire area, is pi r squared. So pi r squared. Okay. So notice, again, a full circle, that angle, we say 360 degrees, or 2 pi. Notice this is only 1 pi. So an idea is then, all right, if I take 1/2 of the full angle, multiplied by r squared, I could get the area. That's the same thing we have above, right? But what if the angle is not 360 or 2 pi, just like that other example? right? What if it's only this much? What if we are only doing area of that piece? We don't have a formula for this. Is called a sector, where it's like a triangle, but the end piece is rounded. But it makes sense that in circumference we just change 2 pi to theta, and here I don't really have 2 pi, right? But if I think of it this way, that really is just theta. So we take half of whatever angle we have multiplied by r squared. Okay, and that's the area of just a sector, not the full circle. All right, awesome. So that's where they come from. Hopefully that helps you kind of remember them as needed. One thing to note too, I'm not going to go into in this video, but it's not a coincidence that, notice the pi r and the 2, but here we have the 2 out front, pi r. The pi r remains the same. It's just a matter of, do I put the 2 out front or do I put it as an exponent? So area, it makes sense it's the exponent, because think of like when you do area with units, right? You have like square inches and we write the 2. So maybe that will help you memorize this formula as well. Let's go ahead and move on to the problems. All I did is I gave you 2 examples of these, the way it could be written, but we're going to do both. We're going to do arc length and area. I didn't write, which one to do for which. We will do both. So a circle with radius 12 inches and subtended by a central angle of 45 degrees. Okay, so picture that above, right, 45-degree angle, something like that. And I know that the radius is 12 inches. So to find arc length, right, the S formula, S equals r theta, we need to be in radians. I chose a common angle here. You could, you should know 45 degrees is the same as pi over 4 radians. But if not, just convert it, right? Easiest way to quickly convert to radians is multiply by pi over 180, because pi radians is equivalent to 180 degrees, so that's the quickest conversion. And then reduce it, and I could see, oops, I did not mean to do that. I could see that 45 goes into 180 4 times, so that's why we get pi over 4. All right, now the work is quite easy though. Let's switch colors here. So the arc length S equals r, so pi over 4 multiplied by 12, and using units, this is in inches, so therefore we just get 3 pi inches. But it would be weird to tell somebody, hey, I measured this arc length, right, and I got 3 pi inches. They're like, what is that? So just use a calculator. It's approximately 9 point whatever, 9.14 times 42-ish, right? I'm not a big stickler on how much you round or anything, because at this point you should be able to round, and you could use a calculator to multiply 3 times pi. Alrighty. Area. Now that we have pi over 4 radians, it's a matter of just substituting that into the equation as well. 1/2 multiplied by pi over 4 multiplied by r squared, so 12 squared. So that's 144 pi over 8. And we're doing area now, right? This first one is length, so it's just the unit is inches, but this is square inches. And we can reduce, I believe 8 goes into 144 actually. 18 times, 18 pi, I believe. Okay, and then again, to say the area is 18 pi square inches, that's weird. Use a calculator. Okay, whatever you get, multiply that out. Alrighty. Next one. So now we're doing the description is a sector of a circle with diameter 10 feet and angle pi over 2. So this sector, the diameter now, careful of what they give you. The diameter is 10 and the angle is pi over 2, which is a half circle. Well, more than one approach in this one, because if I know the original formula for circumference, and we could do this with every single one too, but the full circle is 2 pi r, so I know whatever I get cut in half, right? Because I have a semicircle. The trick here, though, notice it's not 10 is the diameter, right? 5 feet is the radius. Both of these formulas require the radius, not the diameter. So let's go ahead and do it. I think from there, this problem is pretty straightforward. So S equals r theta. So 5 multiplied by theta, pi over 2. So we get 5 pi over 2. And this is in feet. Again, use a calculator. I don't know what that would be. I'm not even going to try. And then for area, we do 1/2 of theta. So 1/2 multiplied by pi over 2 multiplied by 5 squared. So pi over 4 multiplied by 25. So we get 25 pi over 4. This is, again, feet, square feet, since we are doing area. And this one, I had this one written out. Let's see. I think we get 19.6-ish. So depending on where you want to round, 19.6-ish square feet.